Hi, I'm Professor Angela Rasmussen from the University of Utah Electrical and Computer Engineering Department, and I'm going to talk about partial fraction expansion. So the goal of today is to understand how to manipulate an S-domain equation to achieve the equation from a partial fraction expansion to be able to match it up with the Laplace transform tables so that you can then change it into the time domain very easily. So this is the problem we're going to look at, and there's going to be a couple different ways you can actually go about finding the variables for A, B, and C. So we know from partial fraction expansion that it's going to be of this form, where we have A over the S plus 2, B over the S plus 2 squared, and C over the S plus 2 cubed. And so this is going to be our form. Sorry. That should be cubed there too. All right, so what we're going to do is multiply both sides by S plus 2 cubed. And when we do this, we have this side will have this cancel, and on this side, the S plus 2 will cancel with the C1. This doesn't cancel up here though. So as I rewrite this, you have 4s squared minus 15s minus 10 is equal to A, and then when that's multiplied out, you get an S plus 2 still on the top, and B for an S plus 2, and then plus C. So this will be our equation. We can set it to be now S equals A minus 2. And so when we set it equal to a minus 2, we note that these terms here actually go to 0, so A and B will go to 0, which makes it really nice. And then we just have that C is equal to 4 times S it's equal to minus 2 squared, so that's going to be another 4, minus 15 minus 2 minus 10, 16 plus 30 minus 10. And so we get C is equal to a 36. So now to find A and B, we're going to differentiate the equation. And so we're going to differentiate the 4s squared minus 15s minus 10. And when we do it to one side, we have to do it to the other side. So we're also going to differentiate the other side. As I miswrite this other side. So when we've multiplied it already, this becomes AS plus 2 squared plus BS plus 2 plus C. All right, now when we differentiate this equation, on the left we get the 2 comes down from the S, so we get 8s minus 15, and then the 10 is 0. And on the right side we get A times 2, and then S plus 2, and then differentiating that inside is just a 1 from the S. And then again on this one, S plus 2 just differentiates to the S as 1. And then C goes to 0. And again, we're going to evaluate it at minus 2. So minus 2 plus 2 is going to put this term to 0. And then we get B is equal to 8 times a minus 2 minus 15, or minus 16 minus 15 for a minus 31. And now to find A, we're going to differentiate again. So we're going to differentiate this time the 8s minus 15. And on the right side is going to be A times 2s plus 2 plus B. And this becomes an 8 on this side, and on this side we have 2a, and then s plus 2 is just a 1. Again, we evaluate it at -2. And so we get the value of A is 8/2 for 4. I'm going to copy this form down. All right, so we had A over S plus 2, so that becomes 4, gets multiplied out, and so 4e to the -2t u of t. And so the next one is S plus 2 squared, so that turns into, the b comes out to the front and gets multiplied, so just 31t e to the -2t u of t. And now for the s cubed, we note that we have a 2 on the top, and so we have to take half of the 36 in order to leave a 2 on that bottom. And so the c term actually needs to be 18 times 2 over s plus 2 cubed. And so the 18 comes out in front. And then t squared e to the -2t u of t. And so this is our time domain expression for that equation in the s domain. All right, we're going to do this same problem, just a little bit different way. So again, this is one way because we have that s plus 2 cubed in order to get the variables. So in this next one, the first part is again exactly the same. We get 36 for c. And now instead of differentiating, we're going to just pick a couple values for s and get the equation for s. So we have not used s is 0 yet, so I'm going to plug that back into this equation. And so the first term goes to 0, the -15 goes to 0, so I'm just left with -10. And on the right side, I have a, and then 0 plus 2 squared plus b, 0 plus 2. And now I already know the value for c, so I plug in 36 for c. So now I have an equation with a and b in it, so multiplying this out, that becomes a 4 plus 2b, and I can bring over the 36 on the other side, so I get a -46, and then I could even solve this for either a or b. I'm going to choose to solve it for b. As I solve that for b, I get a -46 and then a minus for a divided by 2. So I get a -23 minus 2a. And that's a value for b. I can now choose another variable for s, and I'm just going to pick again a random value that's just not s equals -2. 1 is also another easy number. So I plug this in, I get 4 times 1 minus 15 times 1 minus 10. A, 1 plus 2 squared, plus b, 1 plus 2, and then plus c, which is 36. So -15 minus 10 is -25 plus 4, so I'm -21. And then I have 3 squared, so that becomes 9, plus 3b, plus 36. And now I can plug in b. So I bring over the minus 36, 9a, plus 3 times the b value of minus 23 minus 2a. And this is minus 57. Nine A. There we go. Plus 3 times a minus 23 and then a minus 6a. So on the right side it becomes 3a. I'm just going to write the a on the right just to make it a little easier to have all the variables on the right side. And then I have a minus 57 minus 3 times 23, and then I can divide that by 3. And this ends up being a minus 4. I have a minus sign somewhere wrong. Oh, the minus 23 becomes a positive. There we go. Okay, and then that is equal to 4. And then plugging that back into a, I get a minus 23 minus 8, which is minus 31. So these are the same values for the variables. And so I get the same equation as I got before because the variables for A, B, and C are exactly the same. So I'm not going to go through that method again. I just wanted to show you the two different ways for repeated roots that you can actually get these values. All right, thank you for watching.